What's going on, guys? In this video we are going to take a look at injective function, or you can call one-to-one function. Injective function says if x1 is not equal to x2, then f of x1 is not equal to f of x2. For example, let's say x1 arrow toward y1, and if you have this x2 arrow toward y1, this is not x2, this one should be x1. Okay, that's what one-to-one function says. Now let's look at these examples. The first question we have, it's asking us to show f of x is equal to 3x minus 2 is injective. Here what we are going to do is we are going to pick up this one. If x1, let's pick up that one. If x1 is not equal to x2, then f of x1 is not equal to f of x2. Okay, if we can prove this one, then this is injective. Now here the contrapositive is easier to prove, so let's take the contrapositive of this one. Contrapositive is basically we negate this one and we write the, like we just switch around. So the contrapositive of this one is going to look like if f of x1, the negation of this one is equal, and then that is equal to f of x2, then x1 is equal to x2. Okay, this is our claim. If we can prove this one using this, then this is an injective function. Okay, now let's go ahead and pick up this one. Here what we are going to do is we are going to equate f of x1 to f of x2. F of x1 is, here we have 3x minus 2 given, so instead of x we put 3x1. 3x1 minus 2 is equal to 3x2 minus 2. Now minus 2 cancels, and we will get 3x1 is equal to 3x2. Finally we will get x1 is equal to x2. So we proved the claim. It means this is an injective function. Injective. Now let's look at the second. If you want to see this one graphically, let's draw the graph of this one. Here we have 3x minus 2, so it should go through minus 2 and then 3, and here 3 right here. This is minus 2, and if it's 3 right here, then at that point it's going to be 7. What one-to-one function says, if you pick up any x value other than 3, you shouldn't touch this 7 again. That's what it means. Like if you look at this one, this going through this one, this point is not 7, right? So this is the different point, you don't get the 7 for different points. So that's one-to-one function. Now let's look at the second example. Here this question is asking, is f of x is equal to x square is injective. We are going to do the same thing. We are going to prove the contraposition. If we can prove this claim, x1 is equal to x2, then this is injective, otherwise it's not injective. Now let's equate the functions. X square, so I put x1 square is equal to x2 square. If you square root both of them, that's going to be plus or minus x1 is equal to plus or minus x2. Here you can see this is not injective, because for positive x1, for plus x1, you can get negative x2. Okay, because if it's positive, then both has to be positive. This means, for example, if you say 3, it's like 3 is equal to negative 3. That cannot happen. Example. Okay, now let's look at the graph of this one. So this is the answer is no, not injective. Not injective. Injective. Now let's look at an example. The graph of x square is parabola. So as we mentioned, if it one-to-one function, for example, if we take 3 right here, it's going to meet up with 9 here, right? It's going to meet up with 9 right here. According to one-to-one function, if we pick up any x values, that shouldn't be 9. But here, if you pick up negative 3, that's also going to be 9. That's why this is not an injective function. Okay, and that's it. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.